Greetings to our viewers. My name is Ellen Mateke. I am from Ehlanzeni TVET College, Mashishing Campus, Report 191. And the subject that we are going to present today is Engineering Science N2. The topic that we are going to deal with today is energy and momentum. I believe you have your notebook, scientific calculator, your pencil, your ruler, and your pen. We are going to work together, so we are going to enjoy. Let's start by talking on energy and momentum. Our first instance that we are going to have is energy. What comes to your mind when you hear the word energy? Energy is the ability of the body to do work. We have different forms of energy. Just to mention a few: potential energy, kinetic energy, heat energy, and electrical energy. But in today's presentation, we are going to concentrate more on two types of energy. The first one that we're going to concentrate on is potential energy. What is potential energy? Before I give you a background of potential energy, when you hear the word potential energy, I want you to have an imagination of stored energy. Let's define scientifically what is potential energy. Potential energy is the energy that the body possesses by virtue of its position or state of strain. Potential energy is measured in joules, and I have quite a number of examples of potential energy. A car parked on top of a slope, it's possessing potential energy. There is energy in and there is energy out. A human being sitting on a chair, he or she will be possessing potential energy. It's stored energy. A water in a tank, it's just possessing potential energy. It's stored energy because it's not flowing, it's just stored. So those are some of the examples of potential energy. Then another form of energy that we are going to look on is kinetic energy. Kinetic energy is the energy that the body possesses by virtue of its motion. When we're talking of motion, there is movement now which is taking place. And kinetic energy is measured in joules. I have few examples of kinetic energy. An object rolling down a hill, it's moving, it's no longer just standing, it's now moving, so it's possessing kinetic energy. Person running is possessing kinetic energy. A car which is moving, it's no longer parked, it's now moving, so it's possessing kinetic energy. There is movement which is taking place, so that is kinetic energy. And we need to remember that on kinetic energy, all forms of energy, they are measured in joules. While we are still there, we are going to look on another concept of law of conservation of energy. What do we understand by the law of conservation of energy? Energy cannot be created or destroyed, but it can be changed from one form to another, from potential energy to kinetic energy. Then we save or we conserve the energy. And if I have an example that I can put on, that a person who is standing is possessing potential energy. The moment the person starts moving or running, it's no longer potential energy, it's now changing to kinetic energy. So the law of conservation, it simply means is the transferring of energy from one form to another. Like in this instance, we are using potential energy, changing it to kinetic energy. And this is the theory part that we have. And remember, in engineering science, we deal with two parts, the theory and the practical. On our practical, we'll be doing the calculations. And before we do the calculations, there are certain formulas or certain principles that we need to apply. And in this module of energy and momentum, I'm going to touch on formulas that you are going to familiarize with. The first formula that you want to look on, the gravitational acceleration force. The standard one that we use if the object is going down or is going up, the G, it represents 9.8 meters per second square. And we say that potential energy is the energy that the body possesses by virtue of its position or state of strain. So to calculate potential energy, we say PE, it represents potential energy. Potential energy is equal to mass times gravitational force times height. PE is equal to mgh. Then the next formula that we're going to deal with is kinetic energy. Kinetic energy is represented by Ke. Kinetic energy is equal to half mass times velocity squared. Ke is equal to half mv squared. Then we are going to calculate momentum. Momentum is represented by P, and momentum is equal to mass times velocity. P is equal to mv. Then we are going to calculate time. When we are calculating time, we are going to use the kinetic equation where we are saying V, which is equal to U plus AT. What does V represent? V, it represents final velocity, and U, it represents initial velocity, plus A, it's acceleration. And on acceleration, I want to emphasize that if the object, if it's moving horizontal or if it's moving vertical. If it's moving vertical, which means we are going to use the standard gravitational acceleration force, which will be 9.8. But if it's moving in horizontal, the acceleration will be given. Then T, it represents time. Then another formula that we can use, we are now making V subject of the formula, which is the velocity. And for us to calculate the velocity on this module of energy and momentum, we are going to make V subject of the formula, which is the final velocity is equal to 2 EK. EK, it's kinetic energy over mass when we make V subject of the formula. So on this one, these formulas, you need to put it down first after you read the question, before you answer the questions, because now we know what is potential energy, we now know what is kinetic energy, we now know what is G. So now when we are to do the questions on our practical part, you need to know which formula am I supposed to use and how am I going to apply it depending with the nature of the question. In this regard, now we are going to deal with our previous question paper that's gonna give us a hint on explaining or concretizing what is potential energy, what is velocity, how do we calculate time, and what is momentum. Let's look on our question that we have. The first question, it's saying a stone with a mass of 4 kilograms is dropped down a mine shaft 400 meters deep. Calculate the following: the potential energy of the stone before it is dropped down the mine shaft with reference to the bottom of the shaft. This is our question. First thing, you need to read and understand the question. Then look again on the question. What am I given? And what am I supposed to calculate? In this regard, I want you to move with me because I want you to refer to what I'm working here and what you are working on with so that we see how far we will move together. Let's look first on our question. What are we given? We are going to put down the data. From the question, we are given the mass, which is 4 kilograms. Let's write down data to start with. Data, we have mass, and our mass is 4 kilograms. What else are we given? We are given the height, which is 400 meters deep. The height, 400 meters deep. And the question is saying a stone with a mass of 4 kilograms is dropped down, which means the gravitational acceleration force that we are going to use here, it's 9,8. So our G here is 9,8 meters per second square. This is what we are given. And what are we asked to calculate? We are asked to calculate potential energy. And potential energy, we say PE. And potential energy is equal to mass times gravitational force times height. Do we have all the information now? That's the next question that we need to ask ourselves. Yes, we have everything. So now let's start putting in the figures according to our formula. Our mass is 4 kilograms times the gravitational force 9,8 meters per second square times the height, which is 400 meters. Let's calculate it using our scientific calculator. What do we get so that we will be able to proceed? 4 times 9,8 times our height, 400 meters. And our answer is 15,680 joules. All forms of energy, they are measured in joules. You need to indicate that 15,680 joules. That's our first answer. Then we go back to our question. The second question, what is it saying? It's saying calculate the velocity with which the stone will hit the ground at the bottom of the mine shaft. Here we are asked to calculate the velocity. The first question that we need to ask ourselves, do we know what is velocity? Yes. Velocity is the rate of change of displacement, meaning to say there is movement which is taking place. But in this regard, according to our question, we calculated potential energy, and we say that potential energy is the energy that the body possesses by virtue of its position or state of strain. So here we are going to apply the law of conservation of energy, which states that energy cannot be created or destroyed, but it is transferred from one form to another. So in this regard, we are going now to first find the potential energy at the ground level. In the first question, we calculated potential energy where our height was 400. Now there is velocity, meaning to say that this stone is now moving. So how do we do it? We are going to use our height, and our height is going to be 0. Let's put it potential energy at ground because it's moving. So here we are saying potential energy at the ground. And in our mind, we need to remember we are going to apply the law of conservation of energy. And here, the potential energy at the ground, we are going to use the same formula for potential energy, which is mass times gravity times height. But in this regard, because it's going down, it's no longer on the same way it was 400. It's moving, it's dropped down. So we are going to say our mass, it's 4 kilograms times the 9,8 times our height, which is going to be 0. Let's calculate it. What do we get? What is our potential energy now? 4 times 9,8 times 0. Anything which is multiplied by 0, our answer, it will be 0. So here, our potential energy going to the ground is 0 joules. But if we do this, we are not yet done. We want to apply the law of conservation of energy, where we say energy cannot be created or destroyed, but it is transferred from one form to another. The gain in kinetic energy is equal to the loss in potential energy. So here we are changing potential energy to kinetic energy. And like I said, that the gain in kinetic energy, how does this stone going to gain? Because there is velocity, and velocity, there is movement which is taking place. So it's going to stand on kinetic energy. So we are going to say gain in kinetic energy is equal to loss in potential energy. And here, what is the gain in potential energy and loss in potential energy? Potential energy 1 minus potential energy 2. Where is our potential energy 1? Our potential energy 1 is the potential energy that we calculated when we were having a height of 400 meters. So in the first one, we get 15,680 minus the potential energy at ground level, which is 0 joules. So here we are saying 15,680 joules minus 0. Here, potential energy 1 minus potential energy 2. And 15,680 minus 0. Our answer, it will be 15,680 joules. That's our gain in kinetic energy. So now it means we are going to calculate the velocity. And how do we calculate velocity? We are going to apply the formula for kinetic energy. And what is the formula for kinetic energy? Kinetic energy is equal to half mass times velocity squared. But in this regard, we want to make V subject of the formula. We are now calculating velocity. And on velocity, we are going to use a formula for kinetic energy. Kinetic energy is the energy that the body possesses by virtue of its motion. So here, our kinetic energy, it's K E is equal to half mass times velocity squared. So here we are going to make V, which is the velocity, our subject of the formula. So we are going to say V squared is equal to 2 times kinetic energy over M. M is our mass. This is our formula. So now we want to put in the values. What are the values? Do we have the mass? Yes, the mass, we have it. We are given from the question. Do we have the kinetic energy? Yes, the kinetic energy, we calculated it before. Do we have... Yes, that's all the information that we need. So it's 2 times 15,680 divided by our mass, which is 4 kilograms. Let's put it on our calculator and see what we get. Let's punch it on our calculator. I got 7,840. But remember, it's V squared. So how are we going to remove the square root so that we remain with velocity? We are going to square root this 7,840 so that we'll at the end have our final velocity. Let's square root 7,840. What is our velocity? Our velocity now is 88,543 meters per second. While I'm there, always remember my N2 that we round off to 3 decimal places after the comma and put the correct SI unit. Then we are done on this one on velocity. There are another formula that we can use to calculate velocity, but for now, we are not going to apply it. We'll use it later where we say V is equal to 2GH. But in this case, for us to understand it better, we are going to work with this formula. Then let's move on to our next question. Our next question, it says, calculate the time it will take the stone to reach the bottom of the mine shaft. In this regard, now we are asked to calculate time. How do we calculate time? We are going to use the kinetic equation. And on our kinetic equation, we said that V is equal to U plus AT. And we said that V, it's for final velocity. U, it's for initial velocity. A, it's for acceleration, gravitational acceleration. Like what I said, if it's going down or if it's on the vertical, we are going to use the 9,8. And T is the one that we are asked to calculate. So we are going to make T our subject of the formula, and T is the time. Before we put the figures, we need to put the formula that we are going to substitute. So in this regard, we are going to say T is equal to V minus U over A to make it subject of the formula. V minus U over A. Do we have the final velocity? Yes, we have it from the previous question. What is our final velocity from the previous question? Which is 88,543. That is our final velocity. Do we have initial velocity? Initial velocity is 0. Let's put it here so that we easily remember. 0, that's our initial velocity. And do we have the acceleration? Remember, this question, it says that calculate the time it will take the stone to reach the bottom. When it's going to the bottom, our gravitational acceleration force, we are going to use 9,8. So our G here is 9,8 meters per second square. Let's plug in our figures now. Our V is 88,543 minus our initial velocity 0 divided by our acceleration 9,8. So let's calculate it. 88,543 minus 0 divided by 9,8. Let's put it on our calculator and see what we get. Then our time here, it's going to be 9,035 seconds. Don't forget to put the SI unit. And to round off our answer to 3 decimal places after the comma. Then the last question that we are going to look on is momentum. Momentum, define momentum of a body, calculate the momentum of a 2,500 kilogram truck traveling at a velocity of 40 meters per second. Momentum. Momentum is a product of mass and velocity. That is momentum. How do we calculate momentum? We said that momentum is represented by P, and P is equal to mass times velocity. That is the product of momentum. So here we are saying P is equal to mass times velocity. Our mass in this question, our mass is 2,500 kilograms and our velocity is 40 meters per second. Then according to our formula, P, which is momentum, is equal to mass times velocity. And our mass there, 2,500 times 40. Let's calculate it. Our answer here, 2,500 times 40, we are going to get 100,000. And momentum, it's measured in kilograms, meters per second. Because mass, it's measured in kilograms, velocity, it's measured in meters per second. So this is our answer for momentum. This is our last question. Then now, for more information, if you want to contact us, you can contact us on our website, which is www.ehlanzenicollege.co.za, or Ehlanzeni TVET College on our Facebook page, or on Twitter, you can contact us at Ehlanzeni TVET. Then the last one is on YouTube. You can contact us at Ehlanzeni TVET College. Thank you. God bless you.